coordination polyhedron is called coordination polyhedron. Like if you have 4 ligand or 4 coordination number, either it will be tetrahedral or a square planar. So I'm going to take this. This is your central metal atom or ion, and if it has 4 coordination number, that means coordinate bond is 4. Then either it can be a square planar. So a square planar will have a structure like this, that will be planar. So this is your square planar with 4 coordination number, with coordination number equals to 4. You have 2 types of geometry or a spatial arrangement of ligands. That is, first is a square planar, and the second is basically your what we call tetrahedral, sp3 hybridized. You will see in VVT when I will teach this. This is the ligand. This is the ligand, and this is the ligand, and this is the ligand. So this will be basically tetrahedral. And if you have 5 coordination number, it will be a square trigonal pyramid, bipyramidal. This is ligand. This is ligand. It will be trigonal bipyramidal. Now the next is basically octahedral, which has 6 coordinates number. 1, 2, 3, 4, and this will be your 5, and this will be your 6. So it will be basically octahedral. So please do write it. Please do let me know when you are done with this. Are you done with this?
Yes, sir.
So this is your coordination polyhedron. Now we are going to do some questions regarding the oxidation state of central atom, which is very important. Also, we had completed the ligands, right? All type of ligands. So this is your question. I'm going to give you calculate the oxidation state following central metal atom. CuNH3 for 6 raised to the power plus 3. Second is CuNH3 over 6 Cl3. You need to calculate the oxidation state of the central atom. CuNH3 over 4 Cl2. K2Ed Cl4 CuCl2En whole twice plus. Can you do this? Let me know when you are done with this.
Sir, I'm still doing.
Okay. Alan, are you done with this?
Yes, sir.
Very good. What about you, Anushka?
Sir, can you just explain one?
Okay. See, we need to calculate the central atom oxidation state of central atom, and this is your central atom. So in order to calculate the oxidation state of this, I'm going to take this as X plus NH3, as you already know. What is the charge on NH3? 0. It was in neutral ligands, yes or no? If you remember, on the basis of charge, NH3 is neutral ligand, that means it has 0 charge, yes or no, Anushka?
Yes, sir.
So it will have 0 and 6 NH3 is there. 6 is equal to, there is nothing, then equals to, and is there any charge? It's basically plus 3. So you are going to write equals to 3, and then X into 0, that will be equals to 0. Sorry, 0 into 6, 0. So it will have plus 3. Now come to this. Again, you are going to take X plus NH3 has, you know, that 0 oxidation state, plus there is chlorine. So 3 chlorine is there. 1 chlorine will have -1 oxidation state equals to 0. So you can see X minus 3 is equal to 0. So here again cobalt has oxidation state of plus 3. If you are going to solve the second one, that is this third one, cobalt X 4NH3 is 0, each one will have 0 charge, plus 2 chlorine is there, 1 chlorine will have -1 charge, equals to, there was nothing charge, that's why I had written 0 equals to 0, but there is plus charge, that means plus 1 is there. So I'm going to solve it. X plus 0 minus 2 is equal to plus 1, and it will be X is equal to, when you are going to move it here, it will be in positive, so it will be again plus 3 oxidation state. Now when you are going to solve this part, you know, potassium, 2 potassium is there and 1 potassium has +1 oxidation state, plus PD, I'm going to take X, and then 4 chlorine is there and 1 chlorine has -1 oxidation state, will be equal to 0. Again 2 plus X minus 4 equals to 0. So I'm going to put it X minus 2 equals to 0. So X will be equal to +2. So here palladium has +2 charge. Now if you are going to solve this part, cobalt, again X plus 2 chlorine is there, so 2 into, and 1 chlorine has -1 oxidation state, plus 2 into, again this is EN, that is ethane 1,2 diamine, which is also neutral, so I'm going to put 0 equals to, you can see plus, that means +1 charge, and when you are going to solve it, you will get +3. So this is +3 +3 +3 +3, and then +2. Is that clear?
Yes, sir.
Can I change the slide?
Yes, sir.
Now we are going to start this Warner theory. Start Warner theory. Wait a minute. Let's just start nomenclature first. After this part, we will do Warner. So nomenclature of coordinate compounds, coordination compound or complex compound. And in this, we have some rules to follow. Coordination complex compound. First, we are going to learn rules for writing formula. This formula, how we are going to write the complex compound formula. So there are some rules for writing formula. Please do write with me. I'm going to write it with write it. A is basically the central metal atom is listed first. Is listed first. Then ligands are then listed. Then ligands are listed. Ligands are then listed in alphabetical order. In alphabetical order. And their placement does not depend on charge. Does not depend on charge. So first you are going to write it and then I will explain it. C is basically in case of abbreviated ligands like oxalate OX and EN, that is ethane 1,2 diamine. The first letter of abbreviation is used to determine the position of ligands in alphabetical order. Entire coordination entity. Coordination entity, that means ligand and central atom together. Entire coordination entity is enclosed with square brackets. Whether charged or not. Polyatomic ligands are enclosed in parentheses. And also their abbreviation. No space is left in between names of ligand or formula of ligand basically and central atom. The last but not the least, charge of cation or anion is counterbalanced. Is counterbalanced. Please do write it and then let me know.
Sir, done.
Alan, are you done?
Yes, sir.
Very good. So it's very easy to understand. What you need to do, if there is name given or formula, not the formula of the compound, but the name of the compound, what you need to see first, look for the central metal atom and list it. After that, you are going for the ligands alphabetically. You are going to write it, and then if the in case of abbreviated ligands like EN or EDTA, we will consider this first letter of this to list in the formula. Then entire coordination entity, that means coordination entity is enclosed, this entire coordination is entity is enclosed with this square bracket. Is that clear? After that, polyatomic anions like NH3 you can call it, or CO and EN, these are separated with this parenthesis, and no space should be left between names of ligands or central atom. There should be no space. After that, if you have any problem in the charge like cation or anion, if there is a charge, that will be counterbalanced with the help of either counter ion or charge on bracket, charge on a square bracket. Is that clear? I'm going to take an example. Wait a minute. I'm going to take an example. It will be. It is very. Let me take an example. Yes. See, if the name is your tetra amine aqua chlorido, cobalt 3, and there will be a space.
Oh my God, there is a my phone. Huh?
Alan. So Anushka, can you see the name of the compound? Now see what you are gonna do. Tetraamine, that means basically it is ligand. Aqua basically we say H2O. Aqua is for H2O, and then chlorido, which is also a ligand. Cobalt 3. Cobalt is the central atom, so I'm going to list it first, and then alphabetically you are going to write the ligand's name. Tetraamine, that means NH3, tetra, that means 4 times. Aqua, that means H2O. These are polyatomic ligand, that's why I'm going to do the write the parenthesis, and then chlorido, that means Cl. Then close the bracket, and there is chloride, so I'm going to put chloride here. Now see, you will just do as it is, and then you can see in the formula it is given that the cobalt must have oxidation state 3, and you are going to check the oxidation state after writing the formula. So this is X, and as you can see, this is your this is your neutral ligand, that's why it will be 0. H2 is also a neutral ligand, so I'm going to put 0. And as you can see, there is chlorine -1, and there is also a chlorine -1, that will be equals to 0. X minus 2 is equal to 0. X will be equal to +2. But in the question, it is given that it has +3 oxidation state, and you are getting +2. That means it's wrong. So how you are going to balance this charge? You are going to either increase or increase the counter ion. So if I'm going to put the formula like this, you can see the whole will be same. 4, then H2 is there, and then Cl. Then I'm going to increase this Cl to Cl, this chlorine to Cl2. So it will be again, if you are going to check it, it will be -1, and then minus 2 chlorine -2, it will be equals to 0, and it will be. So this will be your right formula. Is that clear, Anushka? The charge will be balanced
Yes,
with the help of counter ions. So please do write it.
sir, could you read the name again?
It's tetraamine aqua chlorido cobalt 3 chloride.
Yes, sir.
Tetraamine aqua chlorido cobalt 3 chloride. Should I repeat it again?
No, sir.
Alan, what about you? Are you done with this?
So,
Okay, Anushka, let me know when you are done with this.
Yes, sir. Done.
Yeah. I'm going to give you push like you're going to write the this is potassium. See, whenever there will be a space between the nomenclature, so if it is written first, that means counter positive counter ion, and if it is written at last like chloride, at it will be negative counter ion. Is that clear?
Sir, could you repeat?
Yeah, wait a minute. Let me write it and then I will repeat. So as you can see in the previous, that there is a space between this and this, right? So I told you that positive counter ion will be on the left hand side of the bracket and negative counter ion will be on the right hand side of the bracket, right? Anushka?
Yes, sir.
So if the space left for the right, this chloride will be used after the bracket. If there is anything that is on the left hand side and if there is a bracket, that will be used before bracket. Are you getting my point? In this case, chlorine is used on the right hand side, and in this case the chlorine will be used on the left hand side because it's positive metal before the bracket. Please do it and let me know if you are facing any problem. Please do let me know if you are unable to solve it. Don't waste your time.
Sir, could you explain?
Yes, why not? See, this is your potassium positive counter ion, so you are going to write K first. Just use K. Then tetrahydroxido zincate. This is your central atom, that is zinc. So I'm gonna write zinc first, and then tetra, that means 4, and hydroxido, that means hydroxide. It is talking about hydroxide, and OH, whole 4. Is that clear?
Yes, sir.
Can you calculate the oxidation state of zinc? No, wait a minute. There was just correct. There was parenthesis. This in bracket shows the oxidation state of the central atom. Please do check. What about you, Alan?
Yes, I'm done.
With everyone, with every question.
Yes, sir.
That's good. So Anushka, if you are going to calculate the oxidation state of this will be X. Potassium has +1, and there are 4. OH has negative sign, hydroxide OH minus, and there is no charge, so there will be 0. If you are going to solve it, you will get +3. But in the question, it is given that it should be +2 oxidation state. So what you need to do, just increase positive sign K2. And if you are going to again solve the oxidation state, you will get +2. So this is the correct oxidation state. So this is the, if you are not getting the correct oxidation state, you need to counterbalance. Counterbalance, that means according to the reaction, or according to the formula, you need to increase or decrease the counter ions if it is given. If it is not given, then we are going to increase or decrease the charge on a square bracket. Is that clear, Anushka?
Yes, sir.
Now, as you can see, there is no space, and basically there is no counter ion. So we will directly jump to the central atom, that is cobalt. And after this difluorido, that means 2 chlorine is there. So I'm going to write it chlorine, that means Cl. After that, bis, that means 2. Ethane 1,2 diamine. So I'm going to write En whole twice, close the bracket. Is that clear?
Yes, sir.
And now, if you are going to calculate the oxidation state, X +2 into -1, and this will be 0 because it's a neutral ligand. So according to this formula, you will get +2 oxidation state of cobalt, which is wrong because in the formula it is given that it is +3 oxidation state. And if there is no counter ion, so what you need to do, you are going to play with the square bracket. You will write it. There was +2 charge, so I'm going to put plus here, and now it will be +3. Now again you can check, this is X +2 into -1 plus this is 0, and that will be equal to overall charge, that is +1. So this will be X minus 2 is equal to +1. If we move there, it will be +3. So this is your correct formula for the given name. Is that clear, Anushka?
Yes, sir. Clear.
Can you do the next? Just let me know if you have any doubt in this. Please do let me know when you are done with this.
Sir, done.
So match your formula. Potassium K, triaxylato aluminum, that means aluminum is here. Triaxylato, that means OX, whole thrice. If you are going to check the oxidation state, if you are putting it 1, yeah, only 1K, so +1. X plus 3. Oxalato has -2 charge. So you will be getting +5 charge. So what I'm going to do, in order to make it 3, I'm going to put K3. As you know that OX has negative charge, -2 charge. So if I'm going to put 3 here, wait a minute. OX has -2 charge and there is 3 OX. That means total negative charge is -6. And in order to make it 3, I'm going to put 3 here so that it will be +3 -6. That will be -3 and move to the right hand side and it will become +3. So now if you are going to check it, it will be 3 into -2 will be equal to 0. And if you are going to calculate it, it will be your. So this will be wrong. This will be correct. So always when you are going to write the formula, first always check the oxidation state of the central atom. If it is equal to the given oxidation state, then it's all good. But if it is not equal, then counterbalance it. Okay, in the way that I did. Everyone done with this? Anushka and Alan.
Yes, sir.
Okay, so this was basically rules for writing formula. Now there are rules for writing your name. There is IUPAC name, as I told you in the previous class. So write some rules for writing. UPSC names of complex compound. UPSC names of complex compound. So the first rule, positive part of complex compound. Positive part of complex compound is named first, followed by negative, After this, ligands are named first in alphabetical order. Followed by central atom, followed by central metal atom. C is prefixes bis, tris, tetrakis. This will be used for complex ligands, are used for complex ligands like ethane 1,2 diamine oxalate ion. These prefixes, wait a minute. Mono, di, tri, tetra, etc. are used to indicate number of ligands, which is elementary ligands, number of ligands. Please do that. After this, name of anionic ligand, which is very important. Name of anionic ligand. End with Why? If there is any cationic ligand. Why? Cationic ligand. And with PM, IUM. For neutral ligands. For neutral ligands. Regular names are used. Regular names are used. Except H2 for H2 aqua is used. Aqua for NH3. Amine is used. For CO, carbonyl is used. And for NO, nitrosyl is used. So please do write up to this and then let me know. It's very easy.
Sir,
Yeah.
sir, could you read what's written after cationic ligands end with?
And with O.
Cationic.
IUM. IUM. Yeah. And with IUM. Whatever is the name in the end, it will be written IUM. There are some more points. Let me know when you are done with this.
Sir, done.
Do let me know when you're done up to this. To write the name, it's very easy. Just keep some rules in your mind and you will
Sir, done.
done. Alan, are you also done with this?
Yes, sir.
So see, I'm going to show you. If this is your coordination compound, this is your complex compound. If it has positive counter ion that will be present here, so it will be written first, then there will be a space. Is that clear? If there is positive counter ion, then it will be written at first and then there will be a space. And if there is no positive counter ion, then we will directly jump on the ligands. Then we will directly jump on the ligands and we are going to write the name in alphabetical order. Okay. Now, the first point is if ligand is negative, then we are going to end its name with O, like Cl negative. We know that chlorine is negative ligand, so it has a name chloride. So in IUPAC, you are going to write it chlorido. OH minus hydroxide. It is hydroxide, right? But now you are going to end this name with O, so it becomes hydroxido. Is that clear? This is what you need to take care of. You are going to write the name of the ligand alphabetically order, and if the ligand is negative, then you are going to end its name with O, and if the ligand is positive, so you are going to end its name with IUM. With IUM, as for example, if you have NH2, NH3 positive, so it is hydrazine. So we are going to write hydrazinium. It is hydrazine. So we are going to write its name hydrazinium. Are you getting my point, Anushka? And if it is
Yes, sir.
neutral, so it will be as it is. Is that clear? Now, after writing the name of the ligands, you will come to the central atom and then write the name of the central atom. Now, when you are going to write the name of the central atom, if there is no charge on the central square bracket, then the name will be written as it is, like zinc, then it will be G. And if there is any hidden, or you can see the charge negative there, then the name end with 8, like we are going to write zincate. Now it becomes zincate. Is that clear? After writing the name of the central atom, you are going to write the oxidation state in parenthesis, and then if there is any negative counter ion, then there will be a space, and then you are going to write the negative counter ion. I will help with an example. Before that, I would like to give you some example of this anionic and cationic ligands. So write with me, it will help you. Anionic ligands with name. So anionic ligand, Cn minus, cyano, and in some books it is written as cyanido, and in some books it will be cyano. Nc minus, that is isocyan or isocyanido, you can write. F minus, what your fluoride it is, but now it will be fluorido. OH minus hydroxide it is, but your hydroxido. You are going to end this name with O. N3 minus azide it is, now its name will be azido. E will be replaced by O. It is nitride, now its name will be nitrito. Nitrito. Is that clear? NO2 minus is there, so its name will be nitrito N. And it is basically your what we say. It is an ambidentate ambidentate ligands. So if you are going to write it in NO2 minus, that means N is donating electron to central atom, and if O is donating central atom to the central atom, so we are going to write it in this form, and its name will be nitrito O. that represents the donor atom is 4. Some of the cationic ligands, the less used NH2, NH2, NH3 positive, that is hydrozonium, hydrozenium, hydrozenium, NO plus nitrosonium, NO2 plus nitronium. Please do that.
Sir,
Yes.
sir, have you corrected the paper?
Yeah, I did. No, wait a minute. Let me tell you. Yeah, Anushka, you got 15 marks. Alan, you got 17 marks.
Sir, how much did I get?
15.
Yes.
Yeah. Okay, wait a minute. You need to do a lot of hard work on this. Martin. Just write it. Anushka, Rahul. Nath. Yeah. Also, there is a request. That is, when you are going to write it, please write it clearly, and also uh, maybe the PDF or your pen. That is, I'm not able to see it clearly. Are you getting my point? If you will look in your PDF in page number second, it is slightly blurred, not that much dark. It is fade. Okay.
Yes, sir.
And attempt at the end. Okay. So second question, it is slightly not very much fade. What about today? You are going to give the second mock test, right?
Yes, sir. For electrochemistry.
Okay. All the best.
Thank you.
Alan, are you done with this?
Yes, sir.
Have you given the test? 2, or you will give it?
So which one?
Mock test 2.
No, I'll give it soon, sir.
You will give it. Okay. All the best.
Thank you, sir.
Please do please do let me know when you are done with this.
Sir, done.
Very good. Alan, you are also done with this, right?
Yes, sir. I'm done.
Thank you. Please do that. Anushka, did you do any one of this? Alan? Anushka, you are not audible. You are still not audible. Alan, what about you?
Yes, I'm done with all three, but I'm not sure about the last one.
Okay, can you tell me the name of the first one? What you have written?
Yes, so then I wrote chlorido nitrito
No. Chlorido C, amine. This is amine. So we will write it diamine.
diamino, yeah.
Diamino, not amino. It is diamino, diamine, and then chlorido. And then comes this NO2. So it will be nitrito, and you are going to represent this N so that it will be, we will be able to understand that this is an ambident.
Yes, sir, the isomer. Yes, sir.
And then come to the platinum. There is directly platinum because there is no charge and also there is no positive counter ion. so that it will be negative. So platinum, and what will be the oxidation state of this? 2. Yes or no? Because this has negative charge, this has negative charge, this is 0, and this is your x. So you are going to solve it, you will get
2
x is
plus.
equal to +2. So this will be the name. Anushka, did you get it?
Sir, you're able to hear me now?
Yeah, what you just said?
Sir, are you able to hear me?
Yeah. Now you are audible.
Yes, sir, I got the correct answer.
Okay. Now see here, if you have positive counter ion, you are going to write it potassium, not tripotassium. With counter ion, you are not going to write tri-ditetra. You are going to write simple potassium, and then there will be a space, and come to the directly jump to the this ligand. Directly jump to the ligand, and then it will be 3 times. That means tri, and it is oxalate ion. So I'm going to write oxalate. Then I remember it is negative ligand, anionic ligand. So the name ends with O, oxalato. Now, see, if you are going to remove this positive counter ion, there will be negative charge. Yes or no? Anushka and Alan.
Yes, sir.
So if there is negative charge on a square bracket, that means the complex is anionic complex it is. So the name and the central metal's name, or the name of central metal atom, ends with A. So chromium is here. So I'm going to write it chromate, and then calculate the oxidation state. It will be 3, and this is the correct name. Whenever there will be directly, you can see directly there will be negative charge, or if there is any positive counter ion, if there is any positive counter ion, there will be indirectly negative charge on this, and that's why the name of the ligand ends with 8. Is that clear?
Yes, sir.
What about the next?
Sir, I didn't do the C and D.
You didn't do the C and D. Please do it.
Yes.
Let me know when you are done with this. What is the name you have written, Alan, for this?
So dichloro best ethane 1,2-diamine cobaltate chlorido.
Wait a minute. Dichlorido base 1,2
Ethane 1,2-diamine.
base ethane 1,2 diamine, then 1,2 diamine,
Cobaltate.
and then
Cobaltate chlorine.
cobaltate or cobalt.
Cobalt. Okay, cobalt and then chlorine 2.
Cobalt 3, right?
Cobalt. Yes, sir. 3.
and then chloride.
Chloride.
It will not be cobaltate because it's not negative charge. You can see if you are going to remove this, it will be positive. So always keep it in mind. If
Yes,
there
sir.
is directly negative charge, then the name of the central metal atom ends with 8. Or if there is any positive counter ion, then the name of the central atom ends with 8. Now see, I'm
Yes, sir.
going to name this. So what you have written, let me just check it. Dichlorido bis ethane 1 comma 2 diamine. Very. Now come to this point. Again, you are going to write it pentamine. Now see, what is this CO3? Do you know what is this CO3? It's CO3. CO3 minus 2. This is carbonate. Yes or no, Anushka? So pentamine
Yes, sir.
carbonate, since it is anionic ligand, so name ends with carbonato. And then cobalt, because there is no negative charge on the square bracket, neither negative charge nor positive counter ion. Then write the oxidation state. Cobalt has X, this is 0. CO3 has -2 charge, and this chlorine has -1 charge. So you can see it has +3 oxidation state, so it will be 3 and then chloride. Please do write it.
Sir, written.
Done.
Yes, sir.
Both of you done. Okay, I'm going to give you some homework for the IUPSC. Write the IUPSC. And please do NCERT questions. Please, after writing this question, please do let me.